Welcome back to The Explainer. Let's jump right into it, because today we are unraveling a modern maritime disaster that is just absolutely fascinating from an engineering standpoint, but completely devastating for the environment. We're breaking down the sinking of the MSC Elsa 3, which went down on May 25th, 2025. And as you'll see, this wasn't some sudden freak accident. No, this was a complex, cascading failure of mechanical systems, compromised structures, and frankly, some severe corporate negligence. I want you to really think about this number right here, 36. That is the staggering number of hours that abnormal pressure readings were just completely ignored by the crew and management before a fatal list developed. 36 hours. This fact alone proves right off the bat that this catastrophe wasn't some unforeseeable act of God. The warning lights were literally flashing for a day and a half before the ship finally went under.
Okay, let's set the scene. The MSC Elsa 3 was a 28-year-old Liberian-flagged vessel. It was supposed to be running a very standard, routine coastal route from Vision to Kochi, hauling about 640 containers. Obviously, it never made it. Instead, it succumbed to an uncontrollable 26 degrees starboard list and completely capsized right off the coast of Kerala, India, eventually settling about 50 meters below the surface.
So, let's treat this explainer like a forensic investigation. We're going to break down the root causes layer by layer, starting with Layer 1, the mechanical trigger. Here is exactly how the dominoes fell on that mechanical side. First, the ship's automated healing tank mechanism completely failed, which forced the crew to rely on manual corrections. Second, as we mentioned, those wildly abnormal ballast pressures were just ignored for 36 hours. Third, because of that, uncontrolled water ingress caused a massive 26-degree list. Fourth, the progressive flooding breached the engine room. And finally, that flooding triggered a total electrical blackout. The MSC Elsa 3 became what the industry calls a dead ship. Stripped of all internal power, the crew literally lost any ability to manually pump water or correct the list. They were sitting ducks.
But you know, a mechanical failure like that is usually just the trigger. Let's peel back Layer 2, the physical vulnerability. According to the preliminary casualty report from India's Directorate General of Shipping, which by the way perfectly aligns with the IMO's Casualty Investigation Code and all the corroborating academic literature, this ship was in a severely compromised physical state way before it ever left port. Investigators found a massive loss of watertight integrity. We are talking specifically about a leaking manhole cover on double-bottom tank number 5 and a highly prominent cracked weld seam in a port wing ballast tank. Because of these latent structural defects, progressive floodwater was discharging directly into cargo hold number 4, so the ship was literally taking on water from within its own degraded framework. Now what's really telling is when you look at the timeline. The vessel was built back in 1997, making it 28 years old. But look right here at 2016. It was involved in a collision off the coast of Yemen, and the DGS report noted that the underlying structural damage from that crash was never actually comprehensively repaired. The hull was basically relying on temporary Band-Aid fixes that finally just gave out under operational stress in May 2025. It was a tragic inevitability.
Which obviously begs the question, how on earth was a vessel in this degraded state legally allowed to operate? That brings us to Layer 3, the systemic rot.
You don't get to that state overnight. There was a long, recurring history of port state control deficiencies with this ship. It was detained in Rotterdam back in 2010 with 21 separate deficiencies. Fast forward a bit, 9 deficiencies in Tuvikaran in 2023, 5 more in Mangalore in 2024. The data paints a picture of a highly dangerous cycle of deferred maintenance. They were essentially patching problems just enough to scrape past inspectors, and that's it.
The DGS report summed this up perfectly, calling out a troubling gap between paper certification and operational safety. Get this, the ship's classification society, Bureau Veritas, had recently certified the ship as completely seaworthy until 2028. They clearly prioritized paper documentation review over actually doing rigorous physical inspections. They maintained this deadly illusion of paper compliance while completely missing the deteriorating hull. And it gets worse when you look at the Safety Management System, or SMS. It was incredibly deficient. Essential spare parts needed to fix these exact ballasting pumping systems had actually been requested by the crew. They were explicitly flagged as critical, yet shoreside management over in Cyprus just left those requests unfulfilled for 8 straight months prior to the final voyage. Can you imagine?
The crew was forced to operate a failing vessel in a continuously degraded state because management just wouldn't send the parts.
But of course, a ship is ultimately operated by people. So the final slice of our Swiss cheese model of failure here is layer 4, the human element.
While the multinational crew definitely had the theoretical knowledge on paper, they completely lacked the practical, real-world training needed to execute emergency manual ballast overrides during a total blackout. On top of that, the crisis management coordination was just incredibly poor when things went wrong. And to make a bad situation even worse, the chief officer had joined the vessel just one single week before the incident. He had practically zero time for a proper handover, or to familiarize himself with the ship's highly degraded, idiosyncratic systems. Talk about an impossible situation. So what happens when all of these layers of failure simultaneously collapse? Let's pivot to the real-world consequences, the environmental aftermath.
Because those sunken containers didn't just hold standard, everyday goods. They unleashed an absolute ecological nightmare in the form of nurdles. If you aren't familiar, nurdles are these tiny, pre-production plastic resin pellets, usually between just 1 and 5 millimeters. Because of their size and buoyancy, they are incredibly persistent marine pollutants. They get easily ingested by marine life, and worse, they act like dynamic little sponges, absorbing toxic chemicals directly from the seawater.
The sheer scale of this spill is heartbreaking. You have volunteer cleanup efforts out there desperately trying to tackle just massive, massive quantities of these polyethylene nurdles. And the ocean currents essentially acted as a giant conveyor belt, sweeping this toxic cargo from the wreck site off Kerala all the way south down to the Kanyakumari coast in Tamil Nadu.
To put some hard data behind that scale, let's look at the Pellet Pollution Index, or PPI. It reached devastating levels. At Kodimanai Beach, the index hit 2,575. At Panavillai Beach, it hit 2,026. Both of these fall into the very high pollution category. This isn't just a messy beach. This represents an extreme long-term threat to the marine ecosystems, the local coral reefs, and crucially, the livelihoods of all the artisanal fishing communities in the region who completely rely on those waters.
So, taking a step back, what does this all mean for us? The overarching takeaway is that the MSC Elsa 3 disaster is not some isolated freak incident. It exposes a multi-generational threat. It highlights this massive global system where aging feeder fleets are deliberately operated under flags of convenience like Liberia and strategically placed on lower regulation routes. Corporate operators are essentially externalizing their own financial and operational risks and dumping them directly onto vulnerable coastal environments.
Which brings us to a really uncomfortable question, and I'll leave you with this final thought. As these aging ships continue to sail the oceans under flags of convenience, hauling tons of hazardous materials, who truly pays the price when paper compliance finally collides with physical reality? Thank you so much for joining me on this explainer. I really hope this structured look helps you see the hidden layers behind global maritime logistics. See you next time.